Hello students, hope you are doing well. Today we'll start with the physics topic 08 Dimensions of Physical Quantity.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Define dimensions of a physical quantity. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. All the derived physical quantity can be expressed using the seven base quantities. They are represented as below: mass, length, time, electric current, thermodynamic temperature, luminous intensity, amount of substance. Here, M stands for mass, L stands for length, T stands for time, A stands for ampere, K stands for Kelvin, CD stands for candela, MOL stands for mole. Let us check our next question. Explain the term dimensional formulae and dimensional equations. The expression of physical quantity in terms of its dimension is called its dimensional formula. For example, dimensional formula for force is mLT minus 2. An equation which contains a physical quantity on one side and its dimensional formula on other side is called the dimensional equation of that quantity. Physical quantities have same derived units, have same dimension. For example, speed v is equal to m to the power 0, L to the power 1, T to the power minus 1. Explain the term dimensional analysis and its applications. Dimensional formulae helps us to understand the physical behavior of a quantity. Two physical quantities having different dimensions cannot be added or subtracted. For example, we cannot add velocity to the acceleration. Similarly, we cannot subtract force from speed. When a calculation involves the multiplication and division of two physical quantities, the dimension of the resultant quantity can be simply obtained by algebraically multiplying or dividing the dimensions of the respective quantities. For example, work is equal to force into displacement. Thus dimension of work is equal to dimension of force. multiplied by dimension of displacement is equal to dimension of force is mlt to the power minus 2. Dimension of displacement is equal to m to the power 0, l to the power 1, t to the power 0. After calculating these values, we get m to the power 1, l to the power 1 plus 1, t to the power minus 2. And the final result is m l to the power 2, t to the power minus 2. How can you check dimensional consistency of equation? Explain with an example. According to the principle of homogeneity of dimensions, all the terms appearing in mathematical equation should have same dimensions. If the same is not true, the equation is said to be incorrect. For example, let us try to prove the below equation in case of free falling body. We know that total mechanical energy is equal to the kinetic energy and potential energy of a free falling body. Therefore, we can write E is equal to half mv square plus mgh. Now, let us check the dimensions. Energy E is equal to ml square t minus 2. Kinetic energy half mv square is equal to, after calculation we get m0 l square t minus 2. The potential energy mgh is equal to, after calculation we get the final result as ml square t minus 2. Therefore, we found that each term of LHS has the same dimension as of energy. Therefore, we can say that the given equation is dimensionally consistent. Therefore, every correct mathematical formula will always follow the principle of dimensional homogeneity, but the inverse is not true. It means a dimensionally consistent equation need not be correct physically. Explain with an example how dimension can be used to deduce relationship among various physical quantities. Let us consider an example to prove the above. We know that time taken by an object dropped in vacuum to reach the ground depends on two quantities. These are exertion due to gravity g, second height h from where the object is dropped. Let the relation between the three quantities be t is equal to a g to the power x h to the power y. Let us denote as equation 1. Here a is a constant having no dimension. X and Y are power on G and H respectively. If the above relation is correct, then terms on both sides should have same dimension. That is, T is equal to A Z to the power X H to the power Y. T is equal to A G X H Y. We can put the formula for dimension for T, A, G and H. T, it is m0l0 t to the power 1. A is equal to m0 l0 t 0. G is equal to m0 l t minus 2. H is equal to m0 l t 0. After solving this equation, we can get x plus y is equal to 0 and minus 2x is equal to 1. Therefore, x is equal to minus half and y is equal to plus half. Substituting these values in equation 1, we can get a g to the power minus half, h to the power half, and the value of t is equal to a h by g square root. Give the limitation of dimension methods. If the dimensions are given, physical quantity may not be unique. For example, work, energy, and torque all have same dimensions, but all are physically different. Second, numerical constants cannot be deduced by the method of dimension. Third, the method of dimension cannot be used to derive relation other than the product of power function. The method of dimension cannot be applied to derive formula if in mechanics a physical quantity depends on more than three physical quantities.
Topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.